Welcome back to 2025 question A3. This is an oblique planes question. So the image below shows Lionel Messi receiving an award. The drawing on the right shows the plan and incomplete elevation for a similar award. The top surface of the award is constructed or contained on the oblique plane VTH. So you can see here just about that there's this plane that's been cut or slice taken out of the award, okay, and it's just a rectangular solid or a cuboid, okay. So they've projected up, and what we're looking for is heights along here, okay. So on this plane, what we're going to do is we're going to take horizontal sections through the plane, and that's going to result in horizontal lines on the plane, and that will give us the heights that we need. So if I'm going to take a horizontal section on this plane, it's going to result in lines that are parallel to the HT, because the HT is a horizontal line also. And we know that parallel lines are parallel in all orthographic views. So that's the principle that we're trying to apply. So let's start here with a parallel line to my HT. So that's going to give me a horizontal line. So I'll just use a color now to indicate all of these. All right, so what's happening then is that is a point on the vertical plane or on the VT. So let's bring that up. So that's determining a height. It has already been projected up. All right, and now that same horizontal line, let's just show it in the elevation. Okay, so that's the same line. It's a horizontal line, so it's parallel to my HT. All right, and we're going to repeat that then for each one of those. All right, so let's go with next point up. Use a different color pen for each one of these just to make it clear for you. So parallel to my HT. Okay, so that's finding points on the vertical plane. So we'll have heights on the vertical plane or on the VT. So project that up and up and up. So that's finding us our heights. And then I'm just going to project all of these edges up a little bit so we can find where they're going to intersect. So pick one up here. So right there. The blue one is traveling up here. So onto the same edge like that. And then green or orange is traveling up. That's going to be intersecting this one on the outside. Okay, so that's determined all those points for me. So we've got pink joins to blue, so pink to blue. Blue to orange. And down to my green. And green. Okay, so that's that surface, but we need to finish all of this, including hidden detail. So we've got an edge on the side, bring that down, an edge at the front, edge on this side. We won't forget our hidden detail line then. All right, so that's my elevation completed, including the hidden detail. Now determine the true angle between the VT and the HT. Okay, so at the moment that surface is sloping. Okay, so we need to roll back that surface down so that it's resting on the horizontal plane. Okay, so the oblique plane we need to rotate down until it's resting on the horizontal plane, and we'll see the true angle between them. Okay, so it's rotating about the HT. So we need the VT to rotate down. All right, so let's get a color here to show that. Okay, so I need a height. Okay, so I can take this anywhere. I'll go about here, and this is going to be my height. Okay, and I'm going to use that as a reference now to roll back that surface down. So about my VT, HT, sorry. We're going to roll back that down. So, okay, now that height line is going to travel perpendicularly across the HT. It's rotating down like that, so perpendicular to the HT. Until we hit that line there, the rotation. Okay, so that's gone through at 90 degrees. Right, and here then is my VT, and we'll call that V1. All right, so determine the true angle between them. Here we have the true angle, we just need to measure it. Measure that now. Line up my bullseye. Need to extend that out a little bit more so I can see the measurement. I've got that at 64. Okay, so 64 degrees there. This is my true angle. All right. So that's a nice part A in particular is pretty nice, and then determining it, that comes up sometimes. You just need to know that construction for determining the true angle. Okay, so that was our oblique planes question on 2025.